The next product up for milling we call Camworks Milling Standard. Camworks Milling Standard includes all of the functionality in SOLIDWORKS CAM Standard, SOLIDWORKS CAM Professional, and Camworks Standard. And it adds advanced 3-axis milling cycles, including pattern project, constant step over, pencil milling, curve project, and legacy rough and finish milling. These cycles are ideal for doing 3-axis surface machining. So next, let's take a look at how these advanced 3-axis milling cycles can be used to machine a variety of 3-axis parts. So here's a mold for a PVC fitting in SOLIDWORKS assembly mode, and this is a part I might want to machine out of aluminum. And so what I'd like to do is program this part using Camworks Milling Standard. So let me go over to the Camworks feature tree, and then we will start by selecting the machine that we want to use for machining. And you can see here I have a Haas VF3 selected. And if I go down to the active machine and edit it, you can see where I can now see the vise and part set up on the machine that I might want to use to machine this part. So the Haas VF3 in this case. And this is the new machine aware programming that's available in Camworks. So you can see that here. I'll go ahead and close that out. Say OK here. And I can, at any time, I can display that machine if I'd like by using the display components toolbar here and turn on or off the machine to be able to visualize what the part will look like when it's set up on the machine. Now what I can do is go to the part manager and select the part that I would like to machine, and that's that component of the assembly that I would like to machine, and I'll add that to the part manager. And now what I'll go ahead and do is extract the machinable features of the part. So we'll run automatic feature recognition, and it found a couple of holes here, the set of counterbore holes that you see here, and then the 2 dowel pin holes that you see on either side of the part. And under the feature manager, what I also want to do is create a few more multi-surface features for machining the cavity. So what we'll do here is go ahead and create a multi-surface feature. And in this case, what I'll do is select all displayed. And then for the strategy, I have a stored strategy for machining molds in aluminum. So I'm going to use that strategy here and then create that multi-surface feature. And that'll help me machine, or go ahead and machine the cavity there. What I'd like to do now is select faces here, and what I'd also like to do is select the strategy for the runners. So I'm going to be selecting the surfaces. So this is another way to select what you want to machine, and here I'll just be selecting the surfaces that I want to machine. And go ahead and select the faces that make up the runners here. So just selecting the faces of the part. Oh, there's one back there. And then I'll go ahead and say OK, and that'll create that feature as well for me. And then last but not least, we can always create features by color. So a multi-surface feature using colors. And on this case, I have the gates colored yellow here. So I'll select also the gates in aluminum strategy for machining those gates. So go ahead and say OK. And now you can see that all of those different features have been created for me. Once those are created, then I can go ahead and generate the operation plan, and this uses the technology database to automatically generate all of the operations for machining those different features that I defined. And now what I can do is go ahead and create a contain feature. So I would like to contain the roughing and some of the other operations used to machine the cavity. I would like to contain those within this cavity, this area. So I'm going to create a new contain area, and I can do that right under the operation if I like. I can create void areas as well as contain areas. Let me create a contain area here. And I'll just go ahead and select the faces that make up the cavity. So by just quickly selecting the faces here, I can define the contain area that I want the machining to be contained within. So select these different faces here. There we go. And then I'd also like to select these two little faces here and there. And now we can see the complete area contain area has been defined. And so I'll go ahead and say OK. And that contain area has now been added and it's being displayed for me. Say OK there. And once I've created a contain area like that, I can easily drag and drop it across the other operations. So I'll just drag and drop using my control key to drag and drop that contain area to these other operations that I want to be contained within that cavity. So both those semi-finish, finish for the cavity, and then also the pencil milling for the cavity are using that contain area now. And I can actually see that contain area under each of those. And now I can go ahead and generate the toolpaths for machining. So this will create all the toolpaths now with the feeds and speeds and tooling selected from the technology database. And of course, I've captured my best practices and stored them to the technology database so that it uses my best practices, my machining strategies, feeds, speeds, tools that I'd like to use for machining parts like these. So I have now done that as well, and we can now simulate the machining of the part. And here I'll set it to go to the next operation so we can see at the end of each operation what the part will look like as it's being machined. And here you can see a spot drill, the counterbore there, then the drill for the counterbore as well, or drilled hole there. And then you can see there the rough milling, and that's using the 3-axis volume mill to do that rough milling there, and you can see the steps and also that high speed rough milling using volume mill, and that's the 3-axis volume mill that it creates that 3D rough feature for us. And then I can go ahead and hit play again, and we'll see where the semi-finish occurs here using a larger 12 millimeter ball and mill, and then using a smaller 4 millimeter ball and mill. This will do the finishing on the cavity, and there you can see the cavity has been finished now. And then we can hit play again, and we'll see where the pencil milling occurs at each of these little areas that were difficult to reach for the larger 4 millimeter tool. And then we can go in and do the runners and the gates as well. And then we can go ahead and compare the machined model to the design model, and you can see everything is in green, which is good, net to the design model. If there was any stock remaining, it would be in blue, and you can see some blue there underneath where there is stock there. And then if I gouge the part anywhere, it would be in red. So you can see this looks very good, and I'll say OK, and then say OK again. And one of the things I might point out is that all of this is associative to the design model. So if I go back to the SolidWorks model and I turn on, let me show the part that was actually used to make the mold, and here's the PVC fitting itself. And if I make a change to this fitting, let's suppose I change this diameter right here from 30, let's make it smaller, let's make it 20, for example, and 20 millimeters, and rebuild, then you'll see the part will change. And there we go. And now you can see that the part has been updated, and the mold has also been updated. And thanks to the fully associative Camworks toolpaths, then we go back to the Camworks feature tree. It knows automatically that the part has been changed and that the toolpaths need to be rebuilt. So I'll say OK here. And this will go ahead and rebuild all the toolpaths based on the new design, the design change that was made. So notice how quickly we're able to program a part like this using Camworks, and also how quickly that when changes occur, that the toolpaths and CNC program can be updated automatically. So now it's been updated, and if I go back to simulate the toolpaths, the machining again, and I can always run this one tool at a time, but let's go back and we'll just use the turbo mode again and go to the next operation, and again just step through each operation here, and you can see the roughing, and again you can see where it's been updated to the 20 millimeter dimension that was in the back of the part there, the outlet dimension, and then you can see the rough machining, semi-finish, the finish, the pencil milling, and also the runners as well as the gates have now all been updated. So very quick and easy to be able to program parts like these using Camworks, and also be able to make changes and have them update automatically. And I can compare the machined model to the design model again, and you can see where the new machine model now matches the new design model with the changes. And once I have the program the way I'd like, I can go ahead and generate G-code there and post-process the file, give the file a name, and then we can either step through the G-code, or we can go ahead and just play the G-code, and it will post-process the G-code and have it ready to go to the machine. Okay. Now the operations that have been created in this example include the area clear operation, which was using 3-axis volume mill, and that is an add-on which I highly recommend for machining 3-axis parts like these. Also, the pattern project operation was used for both the semi-finish and finish machining of the cavities and the runners. And then also pencil milling was used as well to get into some of the hard to reach areas. Now, in addition to these operations, there's also other operations and functionality that's available in Camworks Milling Standard. So let's take a look at some of the other operations and features that are available. We'll begin with the curve project operation, which is used to project geometry onto surfaces. And in this example, what I'd like to do is to engrave some numbers onto the surface of this wheel, or wheel cover. And so I have created a SolidWorks sketch here of the numbers that I would like to engrave. And if I get a top view here, you can see that I've created that sketch and I have them placed appropriately as to where I'd like to engrave them. So next, what I can do in order to create the engraving program, I can go to the Camworks feature tree and begin by creating a new mill part setup. That mill part setup specifies the Z-axis direction for machining, and you can see the arrow there has specified the direction for machining. And I'm just going to say OK here, and you can see now I've created that mill part setup. And next what I'll do is create a multi-surface feature. This will be the feature that I would like to engrave onto. And for the feature, what I'd like to do is specify all displayed. That's everything that we see on our screen here. And so now I have that multi-surface feature as well. Next, what I'll do is create the engrave feature for the engraving. So I'll go here and select from this pull down the engrave feature, and sketch 24 is the one that I have specified my engraving on. And then I'll say OK here. And now I have both the multi-surface feature and the engrave feature as well. So now I can go to the multi-surface feature, select it, and specify a 3-axis operation and create that curve project operation for the engraving. I'll select a 1mm ball end mill to do that. And then here I can add that engraving feature to this operation, to the curve project operation. I can also specify the depth for machining here under Z allowance. I'll say minus 0.5 millimeters for the depth for the machining. And then I'd also like to go to the entry retract and make sure this is set to just plunge in. It's very small amount in depth, so I'm just going to plunge in, feed into depth, and then start the engraving. So now that I have all those set, I can preview the operation, and this will create those the engraving toolpaths for the engraving onto the surface. And then I can go ahead and simulate the engraving. So let's go ahead and do that. And you can see how quickly and easily you're able to use that curve project operation to create engraved features like this. Another one of the operations that's available in Camworks Milling Standard is the constant step-over operation. And here we have a forging die for a lifting hook, and this is a good example of where you might want to use the constant step-over operation or pattern for machining. So I'll go to the Camworks feature tree and add the part that I'd like to machine to the part manager. Then I'll go ahead and create a mill part setup to specify the Z-axis direction for machining. And under that mill part setup, I'll create a multi-surface feature of all displayed. Now I've set up a strategy for machining the lifting hook, and so I'm going to select that strategy. And that strategy includes the 2 operations. So I'll go ahead and generate the operation plan, and we can see 2 operations here. One for the area clear, that's to rough the cavity out using a 6mm flat end mill, and then a constant step over operation that I mentioned to machine the cavity itself, to finish machine the cavity. Under that constant step over, I also want to create a contain area. So I want that toolpath to be contained within the cavity, this yellow area that you see here. I also want to create an avoid area. So I want to avoid that surface right there that's also inside that area. So now let me go ahead and generate the toolpaths for machining. And this will create the roughing using the Camworks volume mill, which is a great add-on to the Camworks milling standard, especially for machining 3-axis parts like these. And then the constant step over operation. So here's my roughing operation using the volume mill to rough out the part. And here's that constant step over operation that I mentioned that will do our finish machining. And so if I go ahead and simulate the toolpath now, you'll get a better idea of exactly how this is going to work. And you can see that rough milling occurred there using the volume mill. And then you can see here where it's doing the constant step over operation. And notice how it machines, it creates the toolpaths that are in the shape of the outside profile and offsets those all the way down. So you can see what a nice finish it leaves, and how that constant step over operation can be used to really do some nice machining on 3-axis parts like these. I might also mention that you do have the ability to reverse the direction of the machining. So if I go to constant step over and reverse the order, and then say OK and let it regenerate the toolpaths, we'll now start at the bottom of the cavity and machine up which can be even better for surface finish, for a good surface finish, so that you don't end up with chips and that kind of thing, causing a problem at the bottom of the cavity. So we can now watch the toolpath here. This is under turbo mode, of course, and it does the roughing and then starts at the bottom of the cavity and now machines up to the top of the cavity, or top of the part. So that's the constant step over operation. And that about wraps it up for Camworks Milling Standard. Thank you for watching. For more information, go to www.camworks.com or contact your SOLIDWORKS or Camworks reseller.